Everyone, it is my honor to be collaborating with Switzerland again and the high technology community. I absolutely resonate with what I just heard from the presentation from Sulzer. I just dialed in because it's 5:20 in the morning here, but I did hear almost half of the presentation from Sulzer. The idea of removing silos to make human and machine together decisions. When I worked with Bill Gates focused on cutting every problem into as many parallel executable work streams as possible. That was Bill Gates' entire management philosophy. That enabled hundreds of teams and later thousands of teams to execute at the same time without waiting on each other. Most companies have siloed central services like procurement. Then every product waits in a queue for procurement. Bill attempted to have each group have its own procurement. Each group have its own legal response. So each group operated like its own little company. That's why Microsoft Office can release Word without ever waiting on Excel. Then I worked at the Bill and Melinda Gates Foundation on polio vaccination, distribution, water sanitation, and hygiene projects, maternal, child, and newborn health. Definitely not software projects. And I began using Agile in automotive manufacturing as well. In 2010, I first consulted to Tesla when they were creating what is now the Model S luxury sedan. I recommended adding more modularity, what Bill Gates was trying to teach me, so more of the car could be designed, built, and changed in parallel. Then I worked for the leadership team at Amazon. And Jeff Bezos was very strict on small team size. The reason was teams of less than 6 were observed to not need a leader. They could be 100% engineers, electronics, software, procurement, etc. They were able to discern their own highest priority, discern the highest value, and execute on their own. That allowed a higher percentage of workforce. Then I worked at Tesla as a full-time employee in 2020. And I've never experienced anything so fast. I was shocked. I was hired in as the world's expert in Agile hardware. And what I experienced in Tesla was unlike anything I've experienced anywhere in the world, including working with the world's special forces and militaries, in case you were wondering. I've created a 12-step recovery plan for companies that operate with annual budgets to move them towards operating with daily or no budgets like Tesla does. Now, each of the 12 steps is about an hour. The one I think might be most fun for swissT and for me to talk to the other groups and learn about at swissT is how Tesla does digital self-management. And this is actually very similar to what I was starting to hear from the previous presentation at Sulzer. So I'll zoom in here if anyone can see it. It's one of these 12 pieces, the digital self-managing piece. Most car companies update their product every 2.5 years. This is called the minor model change. They'll change the front bumper style. They'll change some of the interior garnish style. They might change some of the electronics hardware, but probably not. More often, they change some of the software. Every 5 to 7 years, you will have a major model change. This is where Daimler Mercedes-Benz will release a new S-Class, or BMW will release a new 4 Series. This is a 5 to 7 year cadence. This is normal in hardware. Tesla does not work that way. Tesla releases 60 new parts in production a day. And the goal is to then retire 61 parts a day. So the total vehicle part count goes down. There's now about 8,000 parts in the Tesla Model 3 and Model Y, and that part number is dropping, even though there are 60 new parts introduced into production, 60, each day. To give a concept of the size of those parts that are changing, for example, the Model S and X luxury products, the headlights, taillights, and charge ports changed in 2 days. From design through procurement to in production and sold, certified road legal, in 2 days. What does that mean to maintenance? It means all parts are backwards compatible, or an adapter is added if the part isn't directly backwards compatible. So if someone has a failed headlight in the field, they would get the new headlight if it's a warranted repair. That way Tesla doesn't have to warehouse and train maintenance staff on previous versions. They always get the new version. That also means the maintenance model for Tesla can't be a profit center, which is why Tesla has to do its own service to survive as a company. For swissT, what I want to talk about is the digitalization that makes this possible. When I was working in Tesla, I would experience 60 new parts I had never seen before every day. Maybe I should say it this way. In Tesla, there is no office. You are in the factory, period. I was operating Agile at Tesla. That's the closest to a thought leader position you could have. And I was in the factory. I would also have to lift 20 kilograms every day and put it into robots to keep the robots running, get robots unjammed, help unload trucks, load trucks, while doing the thought leadership that is my job. Elon Musk does the same. Elon Musk works in the factory physically every day. Elon drills metal, bends metal, loads robots, helps program robots, writes code, just like everybody else. There's not a separate office like most companies have. So what this means is while I'm developing definition of ready and definition of done Agile practices for small, co-located, cross-functional, self-organizing teams, I am also building cars, designing cars, and contributing to manufacturing directly, like everyone. When a new part arrives, a new shape of car, for example, it flows past your area, and you and a self-organizing team is responsible for completing value-added steps to this car. What's different in Tesla is very often you have never seen this car before, ever. This happens multiple times a day. So you have screens above you that show you a three-dimensional scan of whatever it is that's arriving. Now that doesn't directly help you because you're seeing it yourself. But what that three-dimensional scan is also doing is it's running a set of machine learning stacks to determine what we in Agile call definition of ready. Definition of ready is fit for purpose. Is it ready for your value-added steps? You've never seen this thing before. You're trying to determine, are your value-added steps still compatible or still useful to this new thing? And the 3D scanning then applies a heat map to show you, not just dimensionally, but according to all the laws of physics, are you likely to be able to complete your value-added steps as a team? And in general, if it's green, there's also purple and some other codes that mean things. In general, if it turns green, that means you can attempt your value-added steps. Then you have a corresponding digital self-management step about 3 meters away usually that does a similar scan, and this is to a sub-millimeter level, to determine is your step done and ready for the next step. Now, there's a few very important reasons this is dynamic. One, there's no line in Tesla. You don't know where any given part is going to go next after you do your value-added step. It's not always the same spot. There's not a line. These parts are on smart carts for the most part that are not following magnetic tape. They're dynamically called. They're dynamically pulled by wherever they're needed next. And that's in 3 dimensions. They often go up, down, up at an angle, left at an angle. It's like a hexagon floor tile in 3 dimensions are the different angles every part can go from any step. And this flow is dynamic. In fact, it changes all the time. So you don't know where the next part's going to go. So it's important you have a dynamic digital assessment that changes instantly when a different group calls that part to assess if it meets their definition of ready, which has suddenly become your definition of done. It's the same on the input. You don't know where these are coming from. I remember the first time I encountered a gigacast Model Y, where the entire rear third of the car was a single casting. This is what you dream you could do in automotive manufacturing. It costs less to cast a car, to pour metal into the shape of a car, than to stamp it out of panels and stitch them together like every other car is made. It's cheaper, it's safer, it's faster. I was never told a Model Y was going to be gigacast, and one arrived. The back third of the car was a single poured piece of metal, and the middle and front of the car were stamped panels stitched together just like every other car on planet Earth. And I was shocked. And all the people working in the team with me were shocked. And we thought our value-added steps and the new engineering we're doing, because we're making new engineering based on what we think the cars are every day as well. And they're changing 60 parts a day. And the definition of ready light is, the heat map is mostly green. There's some purple. It lets us know, be careful about these areas. We say, okay, let's try. Our value add steps work. The definition of done lights turn green. The car flows on. It's sold. It's sold to a customer. There was one Model Y sold out of that set of production, with the rear third being cast metal. All the other Model Ys sold at that time were stamped metal in the rear third. 45 minutes later, a Model Y with a different rear casting arrives. There's different crease lines, different stress mount points. The interface is the same. The way it connects to the middle third of the car is the same, but the casting is entirely different. It was an experiment to be lower cost, faster to cast, higher safety. And the definition of ready light turns green. We do our work. The definition of done light turns green. Well, it's a heat map, but you can think of it like turning green. And it goes off to be sold. This continued for the entire 12-hour shift I worked there. Every 45 minutes, a new casting arrived. Now, casting is the longest lead operation for most manufacturing companies. You make these huge steel dies, we call them. They're the size of a car, and they weigh even more. And they come in a set, a top and bottom, and then multiple operations to fine tune as they stamp in order or get injections in order. And these things are often a 3-month lead time to more than a year. And they cost millions of Swiss franc. You don't want to change these casually. And Tesla changes them about every 45 minutes by having the die manufacturer work in the factory directly next to the stamping and press machines. So the moment they finish a die, it's directly put in the machines while they start machining the next die. And they never stop designing. There's no design phase. This is entirely driven by the in-house developed digital self-management in Tesla. Now, the second part is you can't sell something faster than you can certify it as road legal. No matter how quick your engineering would be and how quick your manufacturing change process would be, you can't sell it until it's homologated road legal. To support that, Tesla has developed what's called factory mode. Factory mode is what autopilot came from. Some of you are aware that most Tesla cars can have lane keeping assist and some type of acceleration and deceleration assist and steering assist in some types of scenarios, and that package is called autopilot. It actually works very well. I drive a Tesla myself and I let it drive me almost everywhere. I don't drive much myself anymore. That came from factory mode. Factory mode is self-certification. From the moment these cars are constructed, they drive themselves on what's called the bamboo line through the homologation tests. The reason this is important is every single Tesla could potentially be unique. Remember, for maintenance, this is possible because there's backwards compatibility between the parts. And if they're not directly backwards compatible, there's an adapter that can enable backwards compatibility. Well, you still have to certify these as road legal. So Tesla works directly with the government authorities to say which questions are important to you for these kinds of changes. The cars then physically conduct those tests themselves. Or if the test is destructive, that's simulated. 1 out of every several thousand cars is physically destructed as well, but that's not to achieve homologation. That's not to achieve certification. That's to check the accuracy of the simulations. The digitalization is that important. Then factory mode physically conducts any non-destructive test in that car. And then that car uploads its real data to the government authorities to say, here's what's different between me and the last car you certified. Here's the answers to the questions you were probably going to ask. May I be certified? It's actually a digital document. It's not quite as first person perspective as I made it sound, but that's the idea. It's a digital document that's sent per car, and the cars are then certified. In the EU, the cars do have to ask for permission before they're manufactured. So the factory mode runs in the cloud and says, we're about to make a car with this new type of adhesive, with this new metal alloy in the rear third of the car, etc. May we be certified? And then once that car is made, its factory mode real world testing is added to that request. Whereas in the US, we can build the car first and then have it test itself and then ask for certification. In the EU, we ask for certification and then build the car. But it's still a per unit basis. And this is entirely driven by the in-house software stack. Now, this software stack has a coupled electronics stack of sensors and compute power. It also runs in the cloud, but it also runs physically in the factory on the Tesla bot prototypes roaming the factory and in every car and in most of the machinery. It's been added to most of the robots. So the digital self-management system is compute electronics, sensors, software, and really it's a massive data set. It's 2 million cars worth of Teslas driving around the world creating usage data, it's factory and manufacturing data, and it's employee data, all the ecosystem operating on the cars. The last part of what I'd like to talk about is the way Tesla uses digital twins. There are right about 2 million Teslas in the world right now. Tesla maintains a 3-dimensional graphic file, a CAD file, of all of them, every single one, a separate file. So there's more than 2 million CAD files, well, collections of CAD files. And that's every part, every bolt, every adhesive bead, every rubber gasket, every nylon bushing, everything. All 8,000 parts for Model 3 or Model Y, the CAD is maintained of that individual car. Then there's accelerated aging simulation being run on every part of every car in real time individually. Now, corresponding physical parts are put in huge test farms to continually validate the simulated aging. Are these parts actually aging this way? But the CAD files, the digital twins of every car, has every part going through a digital aging process to simulate what maintenance could be needed soon. There's a few good reasons for this. Also, if a car reports a likely accident, a 4 times gravity deceleration event in any direction, Tesla simulates what it thinks the effects on the car could be and proactively ages those parts differently. Now, Tesla knows where all the cars are most of the time, how fast they're being driven, what music the people are listening to, how many people are in the car, the temperature of the car. This creates an extremely accurate aging model and usage model. It's the same way Zing or Facebook or LinkedIn or Google tracks every user on the internet. Tesla has the same level of information about every car. Now, as a Tesla employee, I could not see who owned which car. And I could not see who was in which car, but I could see all the cars and know which cars had people in them and how many people and approximately how much they weighed, what position they were sitting in, how fast they were driving. You can see that, but you don't know who it is and who the owner is. There is actually complete anonymity, and that's enforced even to me when I was an employee. What this means is Tesla can proactively dispatch maintenance to swap parts with your permission. You get a ping on your app, on your phone. This happened to me here in Hawaii. I was having a Mai Tai at a bar right over there by the beach, and my app pinged me and said, there's a free hardware upgrade for your Tesla Model 3. It's a new charge port. It will enable faster rate of charging. Would you like it? And I said, sure. And the map showed me the Tesla technician driving to me to the parking garage where I was parked at the resort. And when I saw it getting near, I finished my Mai Tai and I walked to the parking garage where I was parked to see what was happening. And the Tesla maintenance vehicle arrived and a tech came out, and I waited till they were done. It took them about 2 minutes. They popped out the charge port like a big Lego piece, and they popped in a new one, and they adjusted the trim garnish, and they were done. You know, I mean, they did maintenance diagnostics through their app, through their phone, and they were done. And I talked to them afterwards. It turned out they'd worked in the Fremont, California headquarters as well. And we hadn't met each other, but we both worked in the same set of facilities. We had a conversation. And then they went off to their next call because they don't know where they're going to be called next either. It's dynamic through their app. They're called a Tesla Ranger. So the digital self-management model, the digital twin of my car, had actually reported that my charger, because I might be the only car with that charger made out of that type of plastic housing and those types of pins, it was aging. And it could become a maintenance issue at some point in the future. So before it ever frustrated me as a user, it was proactively replaced. And the new version had better cooling. So the new version was able to be charged at a higher kilowatt hour rate. I got faster charge time. That was a free upgrade to me. I didn't even have to go see the car. It happened where it was parked in the parking garage. This is because of the digital twins of all Tesla models. Now that data set has many machine learning stacks running on it constantly to try to determine what information could be helpful to have faster, less expensive, safer manufacturing, faster, longer range, more fun, more environmentally friendly products, ease of use, less frustration to users, less customer interaction. A goal of Tesla is to have the absolute fewest number of inputs from the user possible. If every day at almost the same time I walk to my car, the car will automatically start to preheat itself or adjust itself to my preferred temperature. Now I'm here in Hawaii, I don't need to adjust the temperature for anything ever. I don't use the heater or the air conditioner, but in a lot of parts of the world you would. It goes much beyond windshield wiper sensors, right? The car more and more attempts to avoid any input from the user. If it thinks you like a different kind of music, it's starting to try to guess the music you like much better, right? It's every aspect of the vehicle: seating position, lumbar support, seat temperature, music, steering wheel response. There's attempting to be zero customer input. That's because the digital twin model is such a rich data set for Tesla AI. And this is possible because Tesla AI is an in-house specialty stack that is on continuous releases. Multiple times a day, there's pushes of Tesla AI to all aspects of the factory and all employees' phones. It's on a continuous release cadence, which is the power of what agility is supposed to be. The last part I would wish to mention is what that means for funding cycles. Most companies have a multi-year budget so their employees who are near retirement can plan. So governments they're collaborating with can figure out how to collaborate with them. If you're making 60 part changes a day and deciding what the next set of part changes should be based on what you just learned today, you can't budget. You could not make a year-long budget because you don't know how many certification cycles you're going to go through. You don't know how many part changes are relevant. You don't know what you don't know. Agile companies shorten the budget horizon. There's something called Scrum, which is the gateway to agility. It's like the training wheels, the beginning steps to agility. It enforces a 30-day or less budget. Now, even that's hard. So there's a lot of companies saying they're doing Scrum, but they still have annual budgets. That's actually missing the point. But as you move past Scrum towards actual agility, there's not a rhythm of the budget anymore. It's event driven. It's based on what you just learned. And the Agile manifesto in 2001 says your budgets would be from a couple of months to a couple of weeks with a preference to the shorter time scale. And that coincides with new product development and new product planning and new product release. Well, Tesla is doing 60 part releases a day, so there is no budgeting. Instead, every employee can see the bank account balance on their phone of the company, and every employee can see the rate of spend. Now, in Silicon Valley, for an app company, that's normal. If you were making an app to make coffee cocktail recipes, you could do that. For you and your team of 5 people, maybe even 50 people, you see the company cash reserves and how fast it's being spent, and you try to attract customers and sales ahead of your burn rate, your spend rate. You can imagine that for an app company. In fact, most app companies do run that way. What's strange is Tesla has more than 110,000 employees, more than 500,000 indirect employees, suppliers, core suppliers, and they still run that way. That's what's truly amazing. And that's what enables this digital self-management system to make suggestions in real time that are actionable, because they don't have to wait on a budgeting cadence. They can be immediately executed same day, or in some cases, even same second.